Hi, this problem is basically about decimal number system. In this problem, we have a 5-digit number A, B, C, D, E and it is multiplied by 4 giving another 5-digit number, but the digits are in reverse order. A, B, C, D, E represent 5 digits of a number and E, D, C, B, A represent same digits in the reverse order. We have to find a 5-digit number which when multiplied by 4 produces a 5-digit number again, but with the digits in the reverse order. I rewrite number A, B, C, D, E. It is multiplied by 4. And it gives us a 5-digit number again with the digits in reverse order. E, D, C, B, A. We have to find these digits A, B, C, D, E. We note that on multiplying by 4, we again get a 5-digit number. This means that A cannot be greater than 2. Also, A and E cannot be 0. So we write since A, B, C, D, E, since A, B, C, D, E and E, D, C, B, A are 5 digits number, A and E cannot be 0. We are multiplying the number ABCD by 4. If A on multiplying by 4, if the 5-digit number is to be reproduced again, A must not be greater than 2. A must not be greater than 2. This is because if A is greater than 2, if A is greater than 2, sorry, say we take A equal to 3, then when we multiply this number by 4, then multiplication of A, which is 3, by 4, it will give us 12. When A equal to 3 is multiplied by 4, it will give us 12. And when it is 12, it will produce a 6-digit number. A, B, C, D, A multiplied by 4 will be a 6-digit number. Because we are considering a digit that has highest value, and on multiplication with 4, if A multiplied by 4 gives us 2-digit number, then this is an extra digit that is added and it will produce a 6-digit number, not a 5-digit number. So A must not be greater than 2, A must be smaller than 2. This means that A must be smaller than 2, and this gives us two choices for A. Already we have seen that A cannot be 0, so we have only two choices for A. A can be either 1 or it can be 2. Now we have to choose, we have to find which value of A is valid for the given problem, whether A equal to 1 or A equal to 2. Now the number EDCBA, which is obtained by multiplying the number A, B, C, D, E by 4. This number must be an even number, because it is obtained by multiplying a number by an even number. So when we multiply any number by an even number, the resulting number is also even. So this means that EDCBA is an even number. EDCBA is an even number. Now we note that in the unit place of this number, is A, and for this number to be an even number, A must be 2. We have two choices for A, either 1 or 2. For this number to be an even number, only this choice of A, 2, is valid. So here we have found out that the value of A is 2. This means that 2B, C, D, E multiplied by 4 is equal to E, D, C, B, 2. Note that we have 2 in the unit place, and 2 in the unit place is obtained by first multiplying E by 4. Here we have E in the unit place, and when we multiply E by 4, it leaves 2 in the unit place of a resulting number. We have a number of choices for E. E can have any value. E can have 1, 3, 4, 5, 6, 7, 8 and 9, any of these values. E cannot have value 2 because in the problem it is given that all the digits are different. So once A is 2, none of the other digits will have the value 2. So we have only these choices for the number E. In multiplying this whole number by 4, we first start with multiplication of unit number, and then we move to multiply the number next to it, and so on. That is the basic procedure we follow in multiplying the numbers. So let's write the result of multiplying E by 4E. So when we multiply E by 4, the possible values are 4, 12, 16, 20, 24, 28, 32 and 36. Out of these values, only the value 32 has 2 in the unit place. And to obtain 2 in the unit place of a resulting number, the value of E must be 8, because when we multiply 8 by 4, we get 32 and it leaves 2 in the unit place of resulting number. So for E, this means the result of multiplying E by 4 must be 32, so that the value of E is 8. Now we rewrite ABCD as 2, B, C, D, 8. Value of E is 8. It is multiplied by 4 and it gives us 8, D, C, B, 2. Now again, when we multiply this digit B by 4, it must not generate carry. That is, when we multiply B by 4, it must not be a 2-digit number. 4b must not be a 2-digit number. It is for this reason that if multiplying b by 4 generate a carry, it will add here in the next place, and 4 multiplied by 2 already gives us 8 in this place, which is already present in the resulting number. But if a carry is generated and that carry is added to the result of 2 multiplied by 4, that is to 8, we will not get number 8 here. If there is a carry here, we will get a number greater than 8, but number greater than 8 is not required in the resulting number. We should have only the number 8, and it will be already produced by multiplying 2 by 4. So there should be no carry pass on to this place. So 4b must not generate carry. This means that b should be either 1 or 2. B should be either 1 or 2. If the value of b is greater than 2 or other than these two values 1 and 2, say if the value of b is 3, then this will give 4b equal to 12, and the carry of 1 will be generated, which will have to be passed on to the next place, and it will add to this place and it will give a number other than 8, in particular greater than 8 here, but we don't want a number greater than 8. So b is restricted only to two possible values, 1 and 2, but value 2 is already assumed by the symbol a. A has already taken the value 2, and we know that all digits are different. So when a is already 2, b cannot also be true. So the only choice for b is 1. We write, since all digits are different. B cannot be equal to A, and therefore the only choice for B is 1. So we have found out the value of B also. We rewrite. Now we proceed through usual multiplication, usual procedure that we employ in multiplication of numbers. We first multiply 8 by 4 and it will produce the number 32. 2 will remain in the unit place of a resulting number, and 3 will go as a carry in the next place. And then we multiply 4 with D. This will give us 4D. And to this we add this carry, that is 3. 4D plus 3. And 4D plus 3, this number produces the digit which will appear in the third place. It is the second place. We multiply d by 4 and add carry to it, and we get this number, and this number leaves a certain digit in the next place of the resulting number. This is the third place. So here we note that whatever number results from this expression or this operation, there must be C in the unit place and some digit in the 10 place. It must leave number C in the unit place, because that is what we see here in the place next to 10 place. It must be C, and this number will further go as carry to the next number. And now what are the choices for D? Already we have number 2, 1 and 8. These digits are already present in the given number, and we know that all digits are different. So because all digits are different, D can have the value 3 or 4 or 5 or 6 or 7 or 9. Sorry, there is one mistake. Operation done at this place gives digit 1 in the same place, in the second place, in the resulting number. So when we multiply 4 with D and add this carry, it must give us the number that leaves 1 in the second place or in the 10 place. So it must be 1 here. Possible choices for D are written here. D can be either 3 or 4 or 5 or 6 and so on. So similarly, we can calculate 4D plus 3 using these choices for D. When D is taken 3, it gives us 15. When D is 4, it gives us 19 for 4D plus 3. When D is 5, it is 23. When it is 6, it is 27. When D is 7, we get 31. And when D is 9, we get 39. So among these values of 4D plus 3, only this number 31 can leave 1 in the 10 place. So this is the correct choice for 4D plus 3. So we write 4D plus 3 equal to 31, and this gives us the value of D to be 7. Now we rewrite this expression of multiplying by 4 by taking values for the symbol. 2, 1, 3, 7, 8 multiplied by 4 giving us 8, 7, 3, 1, 2. We use similar reasoning as before to find the value of C now. We multiply 8 by 4 and it gives us 32. 2 remains in the unit position and 3 moves to the next position as carry. Then we multiply 7 by 4 and it gives us 28, and this carry is added to 28 and we will get 31. Out of 31, 1 remains in the next position of the resulting number, while 3 will move to carry to the C position. Now we multiply C by 4 and we get 4C, and to this we add the carry of 3. This operation 4C plus 3 is made in the third position from right, that is the 100 place, and this operation is supposed to leave a digit C in the same place of the resulting number. So 4C plus 3 is expected to produce a number which has C in the unit place, which will occupy the position of 100 place in the resulting number. Note that the number produced by this operation is always a 2-digit number because C represents a digit from 1 to 9. So 4C plus 3 is expected, it can only be a 2-digit number, and we want C in the unit place of the number produced by 4C plus 3. Again we have a number of choices for C. Now we write possible values of C. C cannot be 1 because 1 is already present in the number and all digits are different. C cannot be 1, neither it can be 2, it can be 3 or 4 or 5 or 6 or 9. Now we calculate 4C plus 3. Note that 4C plus 3 can also be written as 4 multiplied by C plus 3, and the resulting number should have C in the unit place. I rewrite the same expression, we want C. So the number we choose for C in this operation, the same number must be present in the unit place. So let's consider the possible values of C one by one and calculate 4 multiplied by C plus 3. When we take C equal to 3, it gives us 12 plus 3, 15. When we take C equal to 4, it gives 16 plus 3 equal to 19. I rewrite them separately. I specifically mention the value of C here. It is 15. When I take 4 for C, it gives us 19. When I take 5 for C, it gives us 23. When taking 6 for C, it gives us 27. And when it is 9, it gives us 39. So note that we wanted the number C, which is multiplied with 4, to be present in the unit place. And if you compare this expression with this last calculation, we see that the number multiplying with 4 is appearing in the unit place. This means that the value of C is 9. And thus we have found out all the digits. So finally we can say that the number A, B, C, D, E is equal to 2, 1, 9, what is the value of D? 7. And the value of E eight. So this is the number which when multiplied by 4 produces a 5-digit number with the same digits in the reverse order, like this. You can check it yourself that when this number is multiplied by 4, it produces 5-digit numbers with the same digits in reverse order. Thank you.